Dears, this is the linkage between the previous lectures. That is, in the first lecture, we have proved that the sum of the first n natural numbers is equal to n into n plus 1 divided by 2. While in the second, we have proved that the sum of the squares of the first n natural numbers is equal to n into n plus 1 into 2n plus 1 divided by 6. While in this lecture, we will try to prove that the sum of the cubes of the first n natural numbers is equal to n into n plus 1 divided by 2 whole square. So before proving this result, let us recall those results which we have proved in our previous two lectures. That is, to prove this result, we suppose that bj is equal to j raised to the power 4. Let us mark this is our first relation. Since we know that aj is equal to bj plus 1 minus bj. Now, utilizing the values of bj plus 1 and bj in this relation, we have j plus 1 whole 4 minus j4. Now in the right hand side, using the formula, so we have j raised 4 plus 4 times j raised cube plus 6 times j square plus 4 times j plus 1 minus j raised 4. So clearly j raised 4 is cancelled with j raised 4, and finally we left with aj is equal to 4j cube plus 6j square plus 4j plus 1. Now using the result j is equal to 1 up to n, aj is equal to bn plus 1 minus b1. Now utilizing the values of aj, bn plus 1 and b1 in this result, we have summation j equal to 1 up to n into 4j cube plus 6j square plus 4j plus 1 is equal to n plus 1 raised 4 minus 1 raised 4. In the right hand side, we have used the result 1. Now in the left hand side, we are applying the summation to each term. So we have 4 times summation j equal to 1 up to nj cube plus 6 times summation j equal to 1 up to nj square plus 4 times summation j equal to 1 up to nj plus summation j equal to 1 up to n1 is equal to n plus 1 whole 4 minus 1. Now using the results, we have summation j equal to 1 up to nj square is equal to n into n plus 1 into 2n plus 1 divided by 6, while summation j equal to 1 up to nj is equal to n into n plus 1 divided by 2, and summation j equal to 1 up to n 1 is equal to n times 1. Now first simplifying the terms in the left hand side and then transferring all those terms which containing n from left hand side to the right hand side. So we have 4 times summation j equal to 1 up to n j cube is equal to n plus 1 whole 4 minus 1 minus n into n plus 1 into 2n plus 1 minus 2 times n into n plus 1 minus n. Now using algebraic manipulation, we have n plus 1 whole 4 minus n plus 1 minus n into n plus 1 into 2n plus 1 minus 2n into n plus 1. Categorically, it is quite clear that n plus 1 is a common factor among these terms. So taken out this one as a common factor. So this is equal to n plus 1 n2, n plus 1 whole cube minus 1 minus 2n square minus n minus 2n. Further, it is equal to n plus 1 n2 n cube plus 3 times n square plus 3 times n plus 1 minus 1 minus 2n square minus 3n. Now simplifying this, we get n plus 1 n2 n cube plus n square. Now n square is common in the second factor. So we have n plus 1 into n plus 1 into n square. And finally it becomes n square into n plus 1 whole square. Thus 4 times summation j equal to 1 up to n j cube is equal to n square into n plus 1 whole square. Now dividing each side by 4, so we get summation j equal to 1 up to n j cube is equal to n into n plus 1 divided by 2 whole square. And this is what? The proof of the sum of the cube of the first n natural numbers. That is, summation j equal to 1 up to n j cube is equal to 1 cube plus 2 cube plus 3 cube plus ellipsis plus n cube is equal to n into n plus 1 divided by 2 whole square.